air attack warning. You and your family must take cover.
Okay, we're starting a new chapter. It's on probability, and the first section, 3.1, is on probability terminology and notation. So, although I enjoy probability very much, I think it's great, very real world, useful, great skill to have. I'm not looking forward to this lesson though, because this is all about terminology. We've got to define a whole bunch of words here. So I'm going to be revealing the definitions very quickly. You're going to have to hit pause and write them down unless you have incredible penmanship and can write things very, very quickly. So here we go. Probability, you actually studied it in grade 8, and you should know that probability is the mathematics of chance or prediction. It's the likelihood of some event happening. So we often present our probabilities or express the probability of something as a decimal, but you could also do it as a fraction, and a percentage is also possible. Alright, you knew that word. Here's a bunch of other words you might not know. A trial is any operation whose outcome cannot be predicted with certainty. So, for example, tossing a coin or rolling a die. Like, you don't know for sure what's going to happen when you toss a coin. You could say, yeah, I know for sure what's going to happen. It's going to come up heads or tails. Ha ha ha. But you don't know whether it's going to be heads or tails. You don't know when you roll the die whether it's going to be a 1, a 2, a 3, or 4, or 5, or 6. So those are trials. An experiment consists of one or more trials. So you actually do one of these things. You toss a coin, you roll a die, you toss 2 coins, you roll 3 die, you spin a spinner, I don't know, pick a card. All these things are experiments. An outcome. An outcome is the result of carrying out an experiment. So you roll a die and you get a 6. Or you toss 2 coins and you get a tails and a heads. These are your outcomes. The sample space. This is all the possible outcomes you could get, the set of all the possible outcomes. So let's say you flip a coin 5 times and you get tails, 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 tails. Does that mean the sample space is just tails? No, the sample space is tails and heads, because those are all the possible ones. You didn't happen to get heads that time when you were doing it, but it is possible. Okay, so if we go back here, the set of all possible outcomes of rolling a die are 1, 2, 3, 4, 5, 6. The set of all possible outcomes of tossing 2 coins, it's tails, tails, heads, heads, and 1 tails, 1 heads. Okay, an event. An event is a subset of the sample space, one or more of the possible outcomes. Okay, so this is the sample space. If you just take a subset of that, so it could just be one of these things, or it could be a couple of them, or 5 of them, or whatever. You have an event. So 2, 5, 6. I picked 3 of them. Or tails, tails in this one. I just picked one of them. The probability of a certain event, the way we show that is PA. That means the probability of event A taking place. The probability can be within 2 numbers. If we speak in decimals, how small can the probability be and how big can the probability be? The smallest the probability can be is 0, and the biggest the probability can be is 1 if we're talking about decimals. If we're talking about percents, it's 100%. But if we're talking about decimals, it's 1. So 0 is less than or equal to the probability of A, which is less than or equal to 1. So what that means is the probability of some event is greater than or equal to 0, and it's also less than or equal to 1. It's between 0 and 1, and it could be 0 and it could be 1. Okay, so we're going to talk about that now. An impossible event. An impossible event has a probability of 0. And there you go, px equals 0. If an event x does not include any of the outcomes in the sample space. So, for example, roll a 9 on a die. Okay, that's just not happening, right? Unless it's, one of these crazy die that has 24 sides or anything. I'm talking about a standard die. If you roll a standard die, what's the the probability of getting a 9? The probability is 0. It is not going to happen. It's an impossible event. How about a certain event? A certain event would have a probability of 1. It's going to happen. if event y includes all the outcomes in the sample space. So py equals 1. An example of that, if I rolled a die and I said, what's the probability of getting a number less than 15? Well, again, on a standard die, they're all less than 15. So it's going to happen. It's for sure. It's certain. The probability is 1. A fair experiment. A fair experiment is when all the possible outcomes are equally likely. So it's not fair to talk about probability, for example, flipping a coin, if it's a weighted coin and tails comes up way more often. I mean, unless you know how much more often it comes up, and then you can take that into account. But it's supposed to be equally likely to be a fair experiment. The formula, and you know this is really important, but as I said, you know this from grade 8. The formula for the probability of some event, the probability of event A is equal to the number of outcomes which are favorable to A divided by the total number of possible outcomes. Let's say I'm rolling a die. I want to know what the probability is of getting a prime number when I roll a die. Okay, let's start with the bottom number. What's the total number of possible outcomes when I roll standard die? 1, 2, 3, 4, 5, and 6. There's 6 possible outcomes, so 6 goes in the bottom. The ones that are favorable to what I'm looking at are the prime numbers. So which numbers are prime? 1's not prime, I'm afraid. A lot of people think it is, but it's not. 2 is prime, 3 is prime, 4 is not, 5 is prime, 6 isn't. So there's 3 of them that are prime. So you have a 3 out of 6 chance which having getting a prime number when you roll a die. 3 over 6 is the same as 1 over 2. You could also express that as a decimal, 0.5, and you could also express it as a percentage, 50%. Complementary events. Complementary events, actually let's think of this as complementary event. Let's get rid of the S there. Okay, a complementary event. A complementary event, it's the set of outcomes in the sample space that are not included in the outcomes of event A. Some of the definitions are more complicated. When you actually get the example, I think you understand. So the example in this case would be turning over a heart and don't turn over a heart. So those two events are complementary, turning over a heart and don't turn over a heart. Do you remember we learned this word before, complementary, when we talked about sets? And a complementary set is all the stuff that's not in the set you're interested in. It belongs to the universal set, but it's not in the set that you're talking about. Same here. If we're talking about turning over a heart, what the probability of turning over a heart when you flip over a card, then not turning over a heart is the complementary event. So what do you know the relationship is with complementary events? If you were to take these two events, turning over a heart and not turning over a heart, and you add them together, what would you get? You would get 1. Okay, probability of event A and the probability of, this is the complement right here, and the way we say this is A prime. So that's the complement. Should I write that? This is the complement. And you say A prime equals 1. That makes sense, right? Something has to happen. Either A happen or A doesn't happen. And so adding those together has to equal 1. Something has to happen. Another way you can show the complement is in this way. So again, this is our complement here. It's just another way of representing the complement. This is A bar. It means the same thing. Complementary events. A compound event. Compound event, we did a lot of compound event probabilities in grade 8. It's when it's events that are formed from repeated trials or from a combination of simple events. So an example of repeated trials would be flip a coin 3 times, and you want to know the probability of getting tails, 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 or something like that. Or a combination of simple events would be something like flip coin, and roll die. These are 2 simple events, and you're doing both of them. And let's say you want to know what the probability is of flipping a coin and getting heads and rolling a die and getting an even number. You want to know what the probability of both those things happening. So you did a lot of that stuff in grade 8. When you're solving those sort of things, you often will use tree diagrams or tables or stuff like that. And we're going to do a little bit of that now. Okay, a game involves flipping a coin and turning over a card to reveal its suit. So we're not interested in the number or anything in the card, just what the suit is. list the sample space. So remember, the sample space is the set of all the possible outcomes. So if you flip a coin and turn over a card to reveal its suit, what are the possible outcomes? We could flip the coin and get a tails, and flip the card and get hearts. Or you could flip the coin and get a tails and get diamonds. Or you could get tails and spades. Or you could get tails and clubs. Is that it? Nope. You could get heads and hearts. You could get heads and diamonds. You could get heads and spades. And you could get heads and clubs. I hope you're impressed with my spades and clubs drawings. They're pretty awesome. And I suppose we could put them in curly brackets. List the following event as a subset. A red card is pulled and heads is flipped. So out of all these are like the universal set here. It's the sample space. All of the things are possible. We're going to make a subset. A red card is pulled and heads is flipped. So which one of these involves a head being flipped? No, 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 no. Those are all tails. So heads being flipped, yes. And a red card pulled. Do you remember which ones are red? Hearts are red. Diamonds are red. Spades are black. Clubs are black. So if we want to get a red card in heads, it's either heads with a heart or heads with a diamond. That's it. Draw a tree diagram to represent all the outcomes. So I mean, we have all the outcomes up here, but just to practice doing your tree diagrams, because as I said before, many people have troubles with this, I start with a dot and I think of one of the things. So I either think of flipping a coin, or I think of turning over a card. Don't do this. This is wrong. Coin, card. That's wrong. You're going to think of one of those two things to start. So I'll think of the coin, and when so I'll put coin up here. When I flip the coin, what could I get? Heads or tails? Now I'll think of the card. When I flip the card over, how many different outcomes could there be? 4. 1, 2, 3, 4. Could be hearts, could be diamonds, could be spades, or could be clubs, so it's a little messy. What if I got tails when I flip the coin? What could happen then when I flip the card? Well, the same thing. That doesn't impact the card at all. These are independent events, we say. One doesn't impact the other. So as well, boy, I shouldn't have been bragging about my spades a couple minutes back. There you go. There's your there's a representation of all the outcomes. Remember, we look at the last column here. So there's 8 outcomes. This one's heads and hearts, heads and diamonds, heads and spades. Last one here is tails and clubs, for example. Okay, show all the possible outcomes in an array. So you've got 2 here. So obviously what you're thinking of here is the coin. And you got 5 along here. 1, 2, 3, 4, 5. Why do I have 5 along there? That's one too many. Should have 4 along there. And this is the card here. So when you flip the coin, you could get tails or heads. So this will be my tails, 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 heads, heads, heads. When you flip the card, you could get hearts. So there's my hearts column. Here's my diamonds column. Here's my spades column. And here's my clubs column. And there you go, we got them all there. What's the probability of flipping tails and turning over spades? So tails is the top one here, and turning over spades is this one right here. And remember, the way we get probability is we look at all the possible outcomes and we put that number on the bottom. So how many possible outcomes are there here? 1, 2, 3, 4, 5, 6, 7, 8. Or if you want, 1, 2, 3, 4, 5, 6, 7, 8. Or if you want, 1, 2, 3, 4, 5, 6, 7, 8. I suspect the bottom number is 8. And what goes on top is the number of favorable outcomes. In this case, a favorable outcome is flipping tails and turning over spades. There's only one of those, so the probability is 1 over 8. What's the probability of flipping tails and not turning over hearts? So here's the hearts right here. If we want to get a tails, so the top row again, and not get hearts, we have this one, we have this one. I'm sorry the green's still there, and we have that one. So again, there's 8 possible outcomes. The number of favorable ones are 1, 2, 3, so it's 3 out of 8 is the probability. If you want to write as a decimal, it's 0.375. If you want to write as a percentage, it's 37.5%. And we are done.